Hello everyone. Let's talk about the square root property. So the square root property is how we're going to solve equations that have squared exponents in them. And these are equations that sometimes you probably could factor, but here this is just a different way to solve them. Here is an example. X squared equals 25. Well, what we'd really like is just a 1x there. So to solve an x squared, we are going to take the square root of each side of the equation. So if I'm going to write it larger over here, x squared equals 25. So I'm going to take the square root of each side. So remember, taking the square root of x squared gives me x. Now the square root of 25, it could be 5, but it could also be negative 5, because if I go back to x squared, 5 times 5 is 25. But negative 5 times negative 5 is also equal to 25. So this can be plus or minus. So a couple different ways to write this. If you have a plus or minus option in your homework tools, use that. Or you can write 5 and negative 5 if you want to list them. Okay? So let's look at these down at the bottom. Solve the equation x squared equals 81. So square root both sides. So x comes out, and the square root of 81 is plus or minus 9. So that's 9 and negative 9. If you want to write it like that, you can put the little brace things around, like you can see they've done that over here on the left. All right, so suppose you have one that's not a perfect square. If we take the square root of both sides on this one, x comes out. 17 does not have any perfect square in it to be able to simplify, so just put plus or minus square root of 17, or square root of 17 and negative square root of 17. That would be your two options, okay? All right, y squared. So here's one where part is going to come out. So take the square root of both sides. So y equals plus or minus the square root of 50. But 50 is 25 times 2. So the 25 comes out as a 5, and you have a 2 underneath. So y equals plus or minus 5 square roots of 2. So what we are doing is we are isolating the squared term, then take the square root of both sides. Because in these next ones, you can see there's a little more to them. I've got z squared equals, or z squared plus 3 equals 0. So I'm going to subtract 3 from both sides. So z squared equals negative 3. Square root. So I have z equals. Now we have square root of negative 3. We have learned what to do with negatives. That negative can come out as an I, and the 3 has to stay because there's no perfect. And again, this is still plus or minus. So this could be I square root of 3 and a negative I square root of 3. So you can have plus or minus imaginary numbers just like you can just regular real numbers. All right, on this next one, I've got 2w squared plus 98 equals 0. I'm going to subtract 98 from both sides. So 2w squared equals negative 98. Now, I still want to get the squared term by itself, so I'm going to also divide by 2. So w squared equals negative 49. Now we square root both sides. So w equals, the square root of 49 is 7. The negative comes out as an I, so plus or minus I and a 7. Let's write that plus or minus 7i. That looks a little bit nicer. So positive 7i and negative 7i. Okay, let's try another one. X squared plus 45 equals 0. Let's add 45 to both sides. So x squared equals 45. Let's square root each side. So x equals, 45 in itself is not a perfect square, but it has a 9 in it, 9 times 5. So that'll come out as a 3, and a 5 will stay. So plus or minus 3 square roots of 5. Now your square root property could have a quadratic equation in it. So an equation, not just one expression with a squared term. Again, we're going to do the same thing because that is isolated. The squared term's isolated. I'm going to square root that, and t minus 4 would come out. And then I would have plus or minus square root of 15. Still have the plus or minus when you take the square root of the right-hand side. Now, on here, I can't reduce square root of 15. It has no perfect square that goes in it, but I need to solve for t. So I'm going to add 4 to both sides. So this looks a little odd. This is going to be 4 plus or minus square root of 15. So if you were writing that out, the two different answers, that's 4 plus square root of 15 and 4 minus the square root of 15. Okay. Now on this next one, here's where these come in handy. If I were to try and factor this one and set this equal to 0, if I subtract 12 from both sides, I'm going to have a negative 11 over here. I can't find factors of negative 11 that add up to 2. So the best way to do this would be to factor this left side. That is a perfect square trinomial that would be m plus 1 squared equals 12. Now take the square root of both sides. So m plus 1 equals plus or minus the square root of 12. Well, 12 is 4 times 3. So 4 comes out as a 2, 3 will stay. So I have m plus 1 equals plus or minus 2 square roots of 3. Let's bring that 1 over. So I'm going to subtract 1 from both sides. So m equals negative 1 plus or minus 2 square roots of 3. And if you're going to write that out on this one, it's going to be negative 1 plus 2 square roots of 3 and negative 1 minus 2 square roots of 3. Just like that. Let's do another one like that where we have to factor on the left side. So again, m squared plus 10m plus 25, that's a perfect square trinomial. So that's m plus 5 squared equals 7. Square root both sides. So m plus 5 equals plus or minus square root of 7 because 7 does not reduce. Move your 5 over. So m equals negative 5 plus or minus square root of 7. Now, I always like to put my whole number part first and then my plus or minus in the middle and my root part at last, just because it keeps it a little bit neater. All right, so that is using the square root property. Have a great day.